So in this video, I'm going to look at Cournot quantity competition. This is a model of duopoly where there are two firms. So we have two firms in the industry. And let's assume that they produce identical goods. So both firms produce identical goods. In other words, perfect substitutes. And let's also suppose that they incur a constant marginal cost of C. So C per unit of output, per unit of output. So marginal cost of firm 1 and firm 2 is equal to C. You can always have different marginal costs. You can assume C1, C2, and they're different. One is greater than the other and so on. But here we'll keep things simple and assume that both firms have identical constant marginal costs. So if marginal cost is constant, then average total cost is going to be the same here. And let's suppose they face the market demand curve. So demand is given by this equation, price P equals to A minus B times Q, where Q is the industry output. So Q is equal to quantity produced by firm 1, which is Q1, plus Q2. So that's your industry output Q, sum of the two outputs produced by firms 1 and 2. And A is the, a price that's high enough where, quantity is 0, right? And B is the slope of the demand curve. It has a negative slope here. All right, so this is your standard demand curve. Now, given this, these assumptions here and this market demand curve, we are going to solve for equilibrium quantity Q, equilibrium price P, and also the profit in the industry. Since they are just two firms, so industry profit is the sum of the profit made by the two firms, right? So profit of firm 1 plus profit of firm 2, that's going to be equal to industry profit, right? So before we move forward, profit, if you remember, of any firm is going to be total revenue minus total cost, which is same thing as price times quantity minus average total cost times quantity, right? So this is your total revenue, this is your total cost. But since marginal cost is assumed to be constant, C, then average total cost is going to be the same. So average total cost is same as marginal cost if marginal cost is constant, right? So we'll just plug that in here to calculate profit. So keep this equation in mind, the profit function. So next, so we are going to use the concept of Nash equilibrium, which you just learned, and we're going to apply it to the Cournot model here. So we are going to find the Nash equilibrium quantity, and Nash equilibrium prices, and profit, right? So how do we do that? Let's look at it. So let's first write down the profit function of firm 1. And since both firms are identical, you don't have to write down the profit function of the firm 2 because they are identical. So therefore, the profit function is going to be symmetrical here. So let's write down the profit function of firm 1. So pi 1 is the profit of firm 1, which is total revenue minus total cost of firm 1. So what is total revenue? Price. Price, if you remember, is A minus B times Q, where Q is the industry output, the sum of two firms' output. So we can write, instead of Q, Q1 plus Q2. So A minus B times Q minus average total cost, which is same as marginal cost because marginal cost is constant. So C. So this is your price minus cost. So this is your price and this is your cost, right? Average total cost. And then you multiply it by quantity. So that gives you total revenue minus total cost. So then we can further expand it. So let's forget about these things here. So profit of firm one is equal to A times Q1, right? A times Q1. So A Q1 minus B times Q1 times Q1 is B times Q1 is squared. And then minus B times Q2 times Q1. So minus B Q1, Q2, and then minus C times Q1. Right? So this is your profit function of firm one. So next to find for Nash equilibrium, first we need to find the best response of firm one given the output produced by firm two. Right. So keep in mind that we are going to look for best responses, and best responses should match, right? And that's where you have the Nash equilibrium. So the best response function of the firm one, so best response function is also known as the reaction function of firm one, best response function or reaction function. So this is found by through optimization. So basically you have profit function for firm one. You partially differentiate the profit function of firm one with respect to quantity one, right? So the idea is that firm one is going to choose its quantity given by taking into account firm two's output Q2 such that the profit is maximized. So if you do that, so if I partially differentiate it, so del pi 1 over del Q1, so del is basically symbol for partial differentiation. And if you write D, then it's total differentiation. So del pi 1 over del Q1 is equal to A minus 2 times BQ1 from here, right? And A comes from here when you differentiate with respect to Q1. And here, when you're taking partial derivative, you treat Q2, the other variable, as constant, right? That's the trick here. So minus B times Q2, B is constant and Q2 is treated as constant, taking the partial derivative, right? With respect to Q1, and then minus C. And then you set it equal to 0. This is, if you remember, is the first order condition for profit maximization, right? But this is also your best response function because firm one is choosing its output Q1 by taking into account the output produced by firm two, which happens to be Q2, right? So firm one's quantity choice depends on what firm two chooses, right? So that's the best response function. So I can solve for this. We can solve for Q1 here. So Q1 is equal to A minus B times Q2 over 2B, right? So if you solve for Q1, you're going to get this expression. And this, A minus B times Q2 minus C over 2B, right? So that's your expression here. And this is your best response function of firm one given the output produced by firm two. You can also call it reaction function of firm one given the output chosen by firm two, right? They mean the same thing, best response function or reaction function. So this is the best response function of firm one. By symmetry, since we assume that firms are identical, they have same cost, then you can by symmetry just write down the reaction function of firm two. So I don't even have to differentiate it. I can just look at Q1. So instead of Q1, I write Q2, output by firm two, and it's symmetrical. So meaning A minus B, instead of Q2, you write down Q1 minus C over 2B. So if you solve for, by, setting up the profit function of firm 2, partially differentiating with respect to Q2, and then setting it equal to 0 and solving for Q2, you are going to get this expression. But you can just write down by looking at what you got for Q1 by switching, Q1 with Q2. So this is your reaction function of firm 2 given the output produced by firm 1. So now we know we have reaction functions, right? Let me just draw a graph of these reaction functions to give you an intuition here why when we simultaneously choose output, why it results in Nash equilibrium and so on. So let's plot the reaction function of firm 1 and firm 2. So we take, let's say, this quantity space here. So Q1, let's say, is on the horizontal axis, Q2 is on the vertical axis. So if you look at the reaction function of firm 1, it's Q1. So let's just write it down for reference. So Q1 is equal to A minus B times Q2 minus C over 2B. And reaction function of Q2 is equal to A minus B Q1 minus C over 2B. So we can, it's a linear equation, as you can see. So Q1 is a linear function of Q2. So it's going to be a straight line when you plot it, right? So how do we plot it? So let's say you are, let's say if output produced by firm 2, Q2 is 0, what is the output? How would firm 1 respond to that output? So you just plug in 0 over here instead of Q2, right? So instead of Q2, just plug in 0. So then Q1 is equal to A minus C over 2B, right? So if Q2 is 0, then firm 1's output would be, firm 1 would respond to it by producing A minus C over 2B. So let's say A minus C over 2B is some number which is here, some quantity. So we got 1 point, and then we need to find the other extreme point, 2 points we need to draw the straight line. And then what we can do is we can assume, what if firm 1's output, when would firm 1 produce 0 unit in response to some output of Q2, right? So then you can solve for Q2 from this expression here, right? So when would firm choose to produce Q1 equal to 0 for some output of Q2? So solve for Q2. So if you solve for Q2, you are going to get A minus C over B, okay? So A minus C, let's write it down, A minus C over B, some number that's here. So this would be the reaction function of firm 1. So you can connect it with a straight line. So this is the reaction function of firm 1 given the output produced by firm 2. This is also your best response function of firm 1. Similarly, you can find the reaction function of firm 2, exact same logic here. So what you can do is, you go here and say, okay, firm 1 chooses to produce Q1 equals to 0. How would firm 2 respond? So the answer is A minus C over 2B, right? So if firm 1 chooses to produce 0 units, then A minus C over 2B is, let's say, here, A minus C over 2B. And if firm 2, for some output of Q1, some output Q1 here, firm 1 will choose to produce 0 units. So you can solve for Q1, and that will give you the answer A minus C over B. So let's say A minus C over B is somewhere here. Okay. So you can connect those with a straight line, and that gives you the reaction function of firm 2 given the output produced by firm 1. Okay. So now we have plotted the reaction functions of the two firms. So if you remember, the Nash equilibrium is where the best responses match, right? So where do the best responses match here? That is the question. So clearly, best responses match where the reaction functions are intersecting each other. In other words, the best responses are equal there, right? So this is going to be the Nash equilibrium, some output produced by firm 1 and some output produced by firm 2. So this would be the Nash equilibrium in quantity. So we have to solve for this. So intuition is very similar. Let's say firm chooses some output. Let's say firm chooses some output like this, right? What happens? So firm 1 chooses Q1 right here. So on its reaction function, then firm 2, so if that's the case, firm 2 is going to respond to this output by choosing this output on its reaction function, right? So this is the output that we choose. And if that's the case, then if this is the output, whatever this output is, firm 1 is going to respond to it by choosing this output, right? And if this is the output over here, then firm 2 is going to respond by producing here. And as you can see, they're moving towards the intersection point, right? So either direction, you start from this direction or this direction, you're going to converge towards this direction. And this is your Nash equilibrium, where the two reaction functions intersect, right? Two best responses match. So let's solve for the Nash equilibrium in quantities. So the idea is that we have two reaction functions, one for firm 1 and one for firm 2, right? We set them equal. We solve for, we solve them simultaneously. So here, what you're going to do is you just take the value of Q2, right? So Q2, value of Q2 is this. You plug this in here, right? And then you have just one unknown in Q1 and you solve for it. So let's do that. So let's say, so let's write down the reaction functions once again. So Q1, Q1 is equal to A minus B times Q2 minus C over 2B, right? So now what I'm going to do, this is C. Instead of this Q2 over here in the equation, right, this one, I'm going to plug in the reaction function of firm 2. So if you do that, so Q1 is equal to A minus B times Q2, but instead of Q2, I'm going to plug in the reaction function of firm 2, which is Q2 is equal to A minus B times Q1 minus C over 2B, right? So this is your Q2 inside the bracket, right? This thing. And then minus C over here, and then everything is divided by 2B, right? So that's the trick here. You just take the reaction function of firm 2, plug this into reaction function of firm 1, and then you have just one unknown, that's Q1, and you need to solve for that. So let's do that. So here, what we can do is B will cancel out here, right? And then we can write down, so 2 times 2B, this gets multiplied here, so you have 4B. So 4B will cross multiply with this. So you can write 4B times Q1 equals to 4B times A, right? So 4AB, A times 4B, right? So that will give you 4AB minus A plus minus plus B times Q1, then minus plus C, and then minus 4BC, okay, 4B times negative C. So now we have, so we can simplify it further, 4BQ1, and this BQ1 can come to the left-hand side. So 4BQ1 minus BQ1 equals to 4AB. Then you're left with 4AB minus A plus C minus 4BC, right? So 4AB minus A plus B times Q1. Sorry, B we have already removed, so let's erase this. So plus C minus 4BC. All right. So now what we can do is, okay, so let's, I erased that because that was going to be a little more complicated. So let's do it afresh here so that you don't get confused with the simplification here. So what we are going to do first, so let's write down again, Q1 is equal to, so basically 2B gets multiplied with this. So 2 times AB minus B times A, which is AB, minus B times minus BQ, which is plus B squared Q1. And then minus plus BC. And then minus 2BC. And then you divide it by 2B times 2B, which is 4B squared. Right, so this is what we have so far. Then what we can do, we can factor out B in the numerator here because it's common in all terms. So Q1 equals to B, you're factoring out B. So you're left with, from 2AB, so take B out, so you get 2A. Over here, you get A, and then you get plus B times Q1, and then you get just C, and then you get minus 2C. And then you divide it by 4B squared. So now B, the square you can remove with this B, just 1B. So then 4B gets multiplied by Q1. So you have 4 times BQ1. And then this BQ1 over here can come over here. So with a minus sign, so minus B times Q1. And that equals to 2A minus A, which is A. And then C minus 2C is minus C. All right. So then it simplifies further. So 4BQ1 minus BQ1 is 3BQ1, right? 3BQ1 equals to A minus C. And therefore, Q1 is equal to A minus C over 3B, right? A minus C over 3B. So this is the equilibrium quantity, mass equilibrium quantity for firm 1. And since we are assuming symmetry, then firm 2 is also going to produce the same output in equilibrium, right? That's the assumption. They are identical and they have same cost, they face same demand. So in this, when the firms are choosing their output simultaneously, then the mass equilibrium in quantities is given by this expression, A minus C over 3B, right? This is what we have. So if you go back to the graph, so let's look at the graph, right? Reaction function. So here, what you see is this is the equilibrium quantity over here, right? So let's highlight with red over here. So Q1 star and Q2 star are the two equilibrium quantities, right? Where the best response functions match. So this value is basically A minus C over 3B. And this is also A minus C over 3B. All right. So this is what the two firms would choose to produce. So if you knew the values of A, C, and B, these parameters, you can just plug in and you'll know what the quantities are. All right, so the next task is to find out what is the price that the firms would charge. So let's look at it now. So what is the equilibrium price now? So price, if you remember, is equals to A minus B times Q, where Q is the industry output, right? So Q is equal to Q1 plus Q2, right? So what is Q1? We found out it's A minus C over 3B. And similarly, Q2 is A minus C over 3B. So we know the quantity, you add them together, so you'll get 2 times A minus C over 3B. So this is your Q. So now we plug this into the over here, right? And that will give us the equilibrium price, the NAS equilibrium price here. So A minus B times Q, which is 2 times A minus C over 3B. So what do we get here? So next we have, so B will cancel out here. So the price is now equal to 3A, so 3 times A, 3A, minus 2 times A, minus minus plus, so plus 2C, right? So, yeah, and then you divide it by 3. So we are left with 3A minus 2A, which is A. So A plus 2C over 3 is going to be the price. A plus 2C plus 3 is going to be the price. So once again, if you knew what the value of marginal cost C, right, and the parameter A, then you could plug in and you'll get the equilibrium price charged by the two firms. So this is your NAS equilibrium price. And the last task is to find out what would be the industry profit. Keep in mind that we have a duopoly, meaning two firms. So industry profit is going to be profit made by firm 1 and firm 2. But since they are symmetric here, so you can just calculate profit for firm 1, and then you multiply by 2, and that gives you the profit of the industry. So let's look at the industry profit. So we go back to the profit function of firm 1. So profit function of firm 1 is total revenue minus total cost, right? If you remember. So total revenue minus total cost, which is same thing as price times quantity produced by firm 1 minus average total cost times quantity, right? Produced by firm 1. But average total cost is going to be same as marginal cost because marginal cost is constant here, right? That's the sum. So we just need to plug in here. So price minus cost, right? Marginal cost is C, or which is same as average total cost now, times Q1, right? So let's make it small cap. All right. So price and quantities we already know, NAS equilibrium price and quantity. So what about the NAS equilibrium price, right? A plus 2C over 3, right? And minus cost, right? C. And then multiply by quantity of firm 1, right? So what is firm 1's quantity? A minus C over 3B, right? That was the price. Sorry, quantity of firm 1. So this will give you the profit of firm 1. So we have A plus 2C minus 3 times C over 3. And then A minus C over 3B. So A plus 2C minus 3C gives you A minus C over 3. And over here you have A minus C over 3B. So this is basically equal to A minus C whole squared over 9B. So this is the profit of firm 1, right? And similarly, firm 2's profit is going to be identical, right? By symmetry. So the two firms' profit would be equal to the industry profit, right? So 2 times A minus C whole squared over 9B is the industry profit here.